It's chemistry and you are watching Damn Science.
In this video, we will solve the question paper 2-2 of 9701 Chemistry Examination Series October-November 2022. And in this video, we will be solving half of the question paper only. The remaining half we will be solving in the next video. So here is question 1 of this question paper 2-2. Question 1 says species such as NH4 plus or the carbonate ion, that is CO3 2 minus, PO4 3 minus, are the examples of molecular ions. Ionic and covalent bonds both involve an electrostatic attraction between different species. Identify the species that are electrostatically attracted to one another in the following bonds. And the first one is ionic bond. Now the question is asking, identify the species which are electrostatically attracted in ionic bond. So in ionic bond, what are attracted to each other? They oppositely charged ions are attracted to each other. Oppositely charged ions, or you can say positively and negatively charged ions are attracted to each other. In covalent bond, what is getting attracted? Now that is also an electrostatically attracted bond, and here in this bond what is getting attracted is the shared pair of electrons. Shared pairs of electrons, they are attracted to nucleus. So the two nuclei, because at least there will be two atoms bonded here, so the two nuclei are attracted to the shared pair of electrons between these two nucleus, and that is how these two atoms are held together. Let's go ahead with the B part of this question. B part of the question says complete table 1.1 to show the total number of protons and electrons in the molecular ion given here. The molecular ion, first one is NH4 plus. Now what are the total number of protons present in NH4 plus? So what I'll suggest is you can add it on the side, where nitrogen is having 7 protons and 1 proton from each hydrogen, that is total 4 protons from the hydrogen. So the total number of protons I would say are 11. Now according to the system, total number of electrons should be as same as protons, but here it's an ion with a positive charge, so 1 electron less. So the total number of electrons present in this ion should be 10. Now if you talk about carbonate ion, again you can calculate. There are 6 protons from carbon, and then there are 8 protons from each of the oxygen, but then there are 3 oxygens, so multiply by 3. So 24 plus 6 will give us 30 protons in the carbonate ion, and in this the charge is 2 minus, that shows 2 extra electrons, so total number of electrons should be 32. And with the same calculation, if you calculate for phosphate ion, the total number of proton goes 47, and as there is 3 minus, so 3 extra electron gives 50 electrons. So this is how we calculate the protons and electrons of the given species. Now if we go ahead with the C question, where NH4 plus is a Bronsted-Lowry acid. Define Bronsted-Lowry acid. Now Bronsted-Lowry acid is a substance which can donate hydrogen ion. That is the definition of Bronsted-Lowry acid. In place of hydrogen ion, you can write which can donate proton also. That is also acceptable, but prefer writing any one. Now the next sub question says, when NH4 plus is heated with NaOH, a pungent gas is produced. Write an ionic equation for this reaction. Now if we are talking about ionic equation, NH4 plus is already an ion, but out of NaOH, the ion which is going to react with the ammonium ion is the hydroxide ion, that is OH minus ion. If that reacts with the ammonium ion, the pungent gas which is produced is ammonia, and the byproduct should be water. So this is the ionic equation which is producing a pungent gas. Let's go ahead with the next sub question. Here it says the nitrogen atom in NH4 plus is sp3 hybridized. sp3 orbitals form from the mixing of 1 2s and 3 2p orbitals. Sketch the shapes of 2s and 2px orbital on the axis given in figure 1.1. Now if we are talking about 2s, there is a spherical orbital at the center of these three axes. So this is a 2s orbital and 2p orbital. Now they are talking about px. So on the x-axis there is a dumbbell shape orbital and that is called 2p orbital. So this is 2px orbital and this is how you're going to draw it. You can even color it because it's full spherical, but if you leave it circular it is fine. 2s and 2px orbitals are as shown. The D sub question. The D question now is there are many naturally occurring hydrated compounds that contain the anion PO4 3-, that is phosphate ion. Name the anion phosphate that is PO4 3-. Now as I've already spoken it, that's called phosphate ion. So let's write it, phosphate ion. But if we name it fully, phosphate is having the oxidation number of 5, that is phosphorus is having the oxidation number of 5, so you can write as phosphate 5 ion. That is the full name, and I prefer that we can't take a risk, so we need to write it fully only. It is phosphate 5 ion. Now struvite is a soft hydrated mineral with the molecular mass 245.3. The anhydrous form of the mineral has the formula NH4MgPO4. Calculate the number of moles of water of crystallization in struvite. Give your answer to the nearest integer. Show your working. Now what are we supposed to find out is the number of molecules with 1 molecule of struvite. So if we talk about this, then we are given the molecular mass of the hydrated mineral and we are given the formula of anhydrous mineral compound. So for first thing which we are going to do is calculate the molecular mass of the anhydrous mineral with NH4 as one of the ion, magnesium and phosphate ion. So adding all the relative mass of all the elements here, we get 137.3 as the MR. Now this is 137.3 as the MR, that is anhydrous. Now hydrated we have already got, so the mass of the water in 1 molecule, that has to be 245.3 minus 137.3, and if we divide it by the relative molecular mass of water, that is 18, then we get the number of molecules of water. So here we get the answer as 6. If we subtract and divide it by 18, we get the answer as 6, and so the number of water molecules of crystallization will be 6. I hope you understood that we subtracted the mass of hydrated compound from minus the mass of anhydrous compound. That gives us the mass of water molecules. From that mass divide by its MR, then we get the number of moles, or you can say the number of water molecules with each molecule of the struvite. Let's go and see which is the next question here. Next question E here says hydroxide ion reacts with true bromo 2-methyl propane in an SN1 reaction. Now you are already told that it is an SN1 mechanism. The molecular ion CH3 thrice C plus forms an intermediate in this reaction. Draw the mechanism of SN1 reaction of hydroxide ion OH minus with 2-bromo 2-methyl propane. Include the charges, dipoles, lone pairs of electrons and curly arrows as appropriate. Draw the structures of the organic reactant and organic product. The intermediate here is shown with the carbocation form. Now let's first draw what is 2-methyl 2-bromo 2-methyl propane. So if it is a propane, we need to draw 3 carbon with bromo on the second position and methyl again on the second position. So here is our compound. So starting with the partial charges on the bond which is going to be broken. Now which bond is going to be broken? That is carbon bromine bond is going to be broken. So there has to be partial charges, and obviously carbon has a partial positive charge and bromine has a partial negative charge. Now this is the bond which is broken. So and curly arrow from the bond towards the bromine, and so on the second step we need to draw an hydroxide ion with a lone pair and a negative charge. Remember, a curly arrow always has to be from the negative species to the positive species. So in the intermediate we have drawn an hydroxide ion which is attacking the carbocation with positive charge, and so the final product here should be CH3. You can draw a hydroxide ion on the top or a hydroxide ion at the bottom, that doesn't make any difference. So our final product is 2-methyl propane 2-ol, and that is how an hydroxide ion is attacking and undergoing an SN1 reaction with the 2-bromo 2-methyl protein, and this is the whole mechanism steps. The next sub question says 2-bromo 2-methyl propane is a tertiary bromoalkane. Define tertiary bromoalkane. Now if we are specifying bromoalkane which is tertiary, then I would say that it is the carbon, it is in this it is the compound, in which bromine a carbon bonded to bromine, already bonded to bromine is bonded to 3 other carbon atoms, carbon atoms. Now such carbon atom which is bonded to 3 other carbon atoms and bonded to a functional group is called a tertiary compound. Here it's a bromo, so we added a carbon bonded to bromine is bonded to 3 other carbon atoms. Let's see what is the next question. Next question here is the organic compound M forms when 2-bromo 2-methyl propane is heated with ethanolic OH minus. Draw the structure of M. Now if we are talking about an haloalkane where bromo is bonded to an alkane chain is heated with ethanolic OH minus. Ethanolic, you can call it as ethanolic NaOH also. If we are heating this compound with an ethanolic NaOH, then that is an elimination reaction where the halogen will be removed and in place an alkene will be formed. So here suppose if we have such 2-methyl 2-bromo alkane and bromine is totally removed, then the double bond is going to be either here or here or here, but we can draw any one because it ends up in the same structure. So let's draw the structure of an alkene with 3 carbon atom. Bromine is removed from the bottom, so I'm writing CH3 here, a double bond on any one side. So then this carbon is left with 2 hydrogen. The middle carbon is not left with any hydrogen, and the last carbon is again having 3 hydrogen atoms. So here is the structure with an alkene by removal of bromine from the second carbon atom. Now here ends our question 1. Let's go ahead with question 2. Probably this is a question on periodicity. Okay. Question 2. The chlorides of some of the period 3 elements are shown in the table 2.1, and here the period 3 chlorides are all given here with some bonding structure and oxidation state of period 3 elements. Okay. Question A, sub-question A, complete the table 2.1. Identify the bonding shown by each chloride under standard condition. Use C for covalent, I for ionic, and M for metallic. So starting with NaCl. Now NaCl is an ionic compound, so I should write I. AlCl3 is actually supposed to be ionic compound because aluminium is a metal, chlorine is a non-metal, so it should be an ionic compound, but actually it exists as a covalent compound. Okay, even if you write ionic, it is acceptable because it is supposed to be ionic, so both is acceptable. Now silicon tetrachloride is purely covalent and phosphorus chloride is also a covalent compound. If we talk about structure, it's question next point. It says identify the structure shown by each chloride under standard condition. Use G for giant and S for simple structure. Obviously, if NaCl is an ionic compound, is going to be giant. AlCl3 is a covalent, so somebody might think it's a covalent, so simple molecular structure, but actually AlCl3 doesn't exist as a single molecule. It always exists as dimers, and that also in solid form. So one dimer is bonded to another dimer in a giant structure itself. So again, it's a giant, but then the remaining compounds are all going to be simple molecular structure, so I'm writing just S. Now the next sub-question says deduce the oxidation state of the period 3 element in each chloride. Now period 3 element is sodium, so the oxidation state is +1. Aluminium is having the +3 oxidation state. Silicon is having +4 oxidation state. Phosphorus is having +5 oxidation state. Okay, PCl3 here. Now the phosphorus is in +3 state, and sulfur here with +2 state because there are 2 chloride ions bonded to the sulfur. So this is how you are going to write the oxidation state of period 3 elements in the table. Now let's check the B question. Write the equation for the reaction of NaCl and PCl5 with water. Include the state symbols of both equations. Now remember, here we just don't have to write the equations, but we have to include the state symbols also. Starting with NaCl. Now NaCl is, when added to water, it's just going to dissolve, it's not going to react, and we know that NaCl is solid. So when it dissolves in water, it's going to change into the aqueous form of its ion. So we just write Na plus and Cl minus in aqueous form. Now PCl5 when reacts with water, it forms phosphoric acid, that is H3PO4, and also the hydrochloric acid. Now if you balance it, then the chlorine are 5 on this side, so we need to add 5, and now if you count the hydrogen and oxygen, then we need to add 4 for the water molecules. So these are the two equations of the period 3 elements with water. Now C. In C, the gas phase aluminium chloride exists at equilibrium with Al2Cl6 gas as shown. Now this is the equation given where the dimer is in equilibrium with the monomer of the same compound, and the delta H reaction is shown is minus 63 kilojoules per mole. The question says complete the dot and cross diagram to show the bonding in Al2Cl6, that is the dimer of aluminium chloride. Now one partial structure of the aluminium chloride is given and we need to complete it. So let me first start with the aluminium atom of the nearby dimer. So this is an aluminium structure. I should write aluminium here. Now let me finish drawing all the chlorine atoms. Now as shown in the partial structure, I'll draw 2 more chlorine. So here are the 2 more chlorine atoms, and now we are left with 2 more again chlorine atoms because the total chlorine are 6 atoms. Now remember, the remaining 2 chlorine should be at the center, which should be connecting both the aluminium atoms. So one more chlorine atom. again between the two aluminium atoms shared here at the center. So the remaining two chlorine atoms written here. So now let me start drawing the dot and cross here. Now we can see chlorine atom is represented by the dots. Let me make the dots darker. So here are the 6 electrons of the chlorine and 1 in the sharing. So 1 cross from the aluminium side, 1 more cross if I am drawing here, then the same chlorine will be having 7 electrons. 1 is gone in the sharing, but the remaining 2 should go with the other aluminium atom, which is the lone pair of chlorine but forms the dative bond with this aluminium atom. Similarly, for the next chlorine, the lone pair of these chlorine is being shared with the aluminium as a dative bond, and the remaining dot and cross diagram as usual. So this chlorine at the center with 7 electrons as you have already seen, and the remaining part as such, which is the replica of the already drawn or the shown chlorine atoms in the question itself. So here are these 7 dots and 1 more cross from the aluminium side. So you can watch here that this is the lone pair which is being shared with the aluminium atom to form the dative bond, and another chlorine atom again shares its lone pair with the next aluminium atom to form the dative bond. So let me simplify the structure here as aluminium, aluminium, chlorine, chlorine, chlorine here, 6 chlorine atoms shown here. These are the simple covalent bonds. One of it is also a simple covalent bond, but this bond is a dative bond, again a simple covalent bond. So this is how the structure should be. So the dot and cross diagram should be drawn very carefully with 2 chlorine atoms at the center around the aluminium atoms. Now the next sub question 2 says, state the effect of an increase in temperature on the equilibrium mixture in equation 1. Explain your answer. Now if we talk about equation 1, you can see that the forward reaction is exothermic as the delta value is negative. So if the forward reaction is exothermic and we increase the temperature, the equilibrium, we will write the equilibrium shifts left hand side. Equilibrium favors, or shifts, I would better write favors left hand side. You can even write favors reactant side, as forward reaction is exothermic. The forward reaction is exothermic. This is the only explanation we can write for 1 mark, or we can explain in detail if it is 2 marks, that according to Le Chatelier's principle, the equilibrium will oppose the change made to the equilibrium. But 1 mark doesn't need more explanation. Let's see what's the next question here. The next question says, a 3.30 gram sample of a period 3 chloride is heated at 500 Kelvin in a sealed flask. At this temperature, the chlorine is a gas of volume 250 centimeter cube and the pressure in the flask is 323 kilopascal. Use the ideal gas equation PV is equal to nRT to calculate the molecular mass of the period 3 chloride. Deduce its formula. So first, if we have a look at the equation, then we have pressure, we have volume, we know the R and we know the temperature T. So what we don't know is the moles, and that is what we are supposed to calculate. So rearranging the equation, we have it this way and substituting the values. The pressure is 323 kilopascal, so we can write it as into 10 power 3 into the volume. Volume is 250 centimeter cube, but then the volume should be in the meter cube, so it should be 250 into 10 power minus 6 divided by RT. So R is a gas constant which is 8.31 into the temperature. Temperature is 500 Kelvin, and so the number of moles calculated is 0.0194 moles. That is the answer we get for moles. Now from the moles we can calculate the MR, that is N is equal to mass upon MR. We can use this formula which will give us M upon N for the calculation of MR, and if we do that, the mass given here is 3.30 gram divided by the number of moles, that is 0.0194 moles, which gives us the answer of 170 as the molecular mass. So here we have got one of the answer, and MR is 170, and we need to calculate the formula of the period 3 chloride. Now chlorine has the relative mass of 35.5. so what I generally do when such things are given, divide 170 by 35.5. let's see which is the biggest whole number value you get. That is 170 divided by 35.5, and the biggest whole number value you'll get is 4, because the answer is 4 point something here. So that shows that the only possible number of chlorine atoms is 4 chlorine atoms. So the 4 chlorine atoms will give you the mass of 35.5 into 4. And if you want to find out the which period 3 element is there, then we can do it as 170 minus 35.5. So answer is 28. Now 28 is the relative mass of silicon. So silicon will give you the period 3 chloride, that is SiCl4 should be the answer. So here the molecular formula of the period 3 element should be SiCl4. Sorry, this is S, silicon. So silicon tetrachloride is the formula we are expecting. I hope you understand my shortcut method. Other than trying a long trial and error method, this is the method I prefer generally. Let's see what is the next sub question with E. Says an excess of chloride ions aqueous is added to 1 centimeter cube of bromine, which is again aqueous. Describe what is observed and explain your answer. Now that shows that we have some bromine aqueous and we are adding chloride ions into it, or you can say we are adding bromine to the compound of chloride, some chloride ion. Now as bromine is less reactive than chlorine, bromine cannot replace out chlorine from its compound. So what observation we'll write is no change, or you can say that the brown color remains. The reason being is that the orange or you can say the orange color or the red brown color remains, because as bromine is less reactive, what you can write here is that as bromine cannot oxidize chloride ions to chlorine, as it is less reactive, or you can say the oxidizing tendency decreases down the halogen group, and this is the answer you can write for this. You can say is the description from group 7 or 17 chapter. So no change for the same reason. Next is sub question. SCl2 has the molecular mass of 103.1 and is a liquid at room temperature. SBr2 has the molecular mass of 191.9 and is a gas at room temperature. Explain the difference in the physical state of SCl2 and SBr2. Give your answer in terms of the intermolecular force. Now if we are talking about intermolecular force, we can see that SCl2 is a liquid and SBr2 is a gas. That shows that the intermolecular force in the liquid should be greater than the intermolecular force in a gas. That is a common concept. But then what kind of intermolecular force is present between SCl2 molecule? Now as we can see that the chlorine is electronegative compared to the sulfur. So the intermolecular bond or the intermolecular force present should be permanent dipole-dipole force. Now as we can know that chlorine is more negative, the permanent dipole force should be greater because of the greater electronegativity of chlorine. So that's how we are going to explain it here. But then what I prefer is that whenever we are writing an answer, first understand the concept, frame a proper sentence, and then start writing. So here the main concept is that the intermolecular force present is permanent dipole, and that should be stronger in SCl2 because of the higher electronegativity of chlorine. So how are we going to write is that the permanent, directly write explanation in a short sentence. So permanent dipole force, dipole force in SCl2 is greater than SBr2, and reason is that as chlorine is more electronegative, compared to bromine, and that is how it can be explained. Here you have mentioned which intermolecular force and why it is stronger, so here you get 2 marks. Let's go ahead with the next sub question. Next sub question says bismuth is a dense metal in the same group as phosphorus. Draw a labeled diagram to show the bonding in bismuth metal. Now it's clearly said that bismuth is a metal. So the only bonding present in bismuth is the metallic bonding. So what I suggest is that metallic bonding structure has a regularly arranged positive ions. So we can draw positive ions in a regular pattern, one after the other. So here are the circles I'm drawing to present the positive ions. You can draw it bigger, but I'm not drawing it bigger because of the shortage of time. Now you need to add the electrons, that is sea of electrons around all these positive ions. This is how I'm drawing it with the help of dots. Dots here represents the electrons, and as described in the metallic bonding, there are sea of electrons, so we can add as many electrons here all around to show the sea. So here according to the question it says draw a labeled diagram. So I'm labeling this both as positive ions, and then I should label this dots also as delocalized electrons. You can name it as electrons also, but I'm specifying it as delocalized electrons. What I suggest is that when generally we have inner space, we should draw one more layer to show a proper diagram, but I had shortened it to explain you people. But now I can add, as I've already labeled and we have got remained with some space also. So let me finish drawing the delocalized electrons around the positive ions. So this is how we can complete the diagram of a metallic bonding. Now the next sub question says the bismuth reacts with chlorine to form BiCl3, that is bismuth trichloride. BiCl3 is a solid at room temperature. It melts when heated gently. BiCl3 reacts vigorously with water at room temperature to form an acidic solution. Suggest the type of bonding and structure shown by BiCl3. Explain your answer. Now remember, there are two parts of this question. It says suggest the type of bonding and its structure and explain your answer. So what is the type of bonding present in BiCl3? It says that it reacts vigorously with water at room temperature. Now if suppose it's an ionic compound, it's not going to react vigorously, but it's just going to dissolve in water. So if BiCl3 is reacting with water, then the BiCl3 should be having a covalent bonding. So have a simple covalent bond, because reason, as I explained, it reacts with water, because it reacts with water. That's the reason, because ionic compound just dissolves, doesn't react. Now it shows about the structure also. I would say it is having a simple molecular structure. Simple molecular structure. You can write full sentence that BiCl3 have a simple molecular structure. The reason is that it is solid, but it melts gently when heated. So you can say that because it's having a simple molecular structure, because it has low melting point, because it melts easily on gentle heating. So we can say that it has a low melting point, and as it has low melting point, it is having a simple molecular structure. So here ends our question 2, and so the remaining few questions we'll be discussing in our next video.